So today what we're going to do is we're going to just do lesson 3, verify. The word verify is to check, to see if it's true, right? Verify trig identities for a given value. So to verify means to show that an equation is true for a specific value of the variable. It does not prove that the equation is true for all values. So it might work for this one, but there might be other ones might not be true for all possible values. So it says here, verify that the equation cotangent square theta plus 1 is equal to cosecant square theta. And then they say the theta is pi over 6. So what we're going to do is we're going to work out the left side and see if it will match the right side. And that's what verifying or checking, right? What we're going to do is we're going to check. So let's do the left side first. So the left side is cotangent square theta plus 1. It says here we're going to replace the theta with pi by 6 and let's see what happens. So cotangent square of pi by 6 plus 1. Now we're going to take a look at this. We know pi by 6 is one of those special angles, right? So pi by 6 is a special angle. What's pi by 6? Pi by 6 is over here in quadrant number 1. So pi by 6 is root 3 over 2, comma 1/2. Now this is cos theta, sine theta. Cos of pi by 6, sine pi by 6. There's, in this particular coordinate, we don't have the cos. Well, how can we figure out, cotangent. How can we figure out the cotangent of pi by 6? Right, because we know that cotangent is cos theta over sine theta. So cos theta divided by sine theta. So it's going to be root 3 over 2 over 1/2. But there's a square there. So where do we square this piece? We're going to square the cotangent, that value, particular value. So square this plus 1. Okay. There's not enough room in here, and we'll see what happens. So if we simplify the inside, root 3 over 2 divided by 1/2, that's the same thing as just root of 3 squared plus 1. Is everybody okay with that? Can you see that? Okay, I'm just going to go this way. It's going to be root of 3 over 1 squared plus 1. Okay, now let's do, what's the square of root of 3? It would be 3 plus 1, and that becomes 4. So the cotangent square of pi by 6 plus 1, it boils down to the value is 4. Okay, now what about the cosine? Cosecant square theta. Cosecant square theta. Now I'm going to replace theta with pi by 6. So cosecant square of pi by 6. Now, here's pi by 6. What's the cosecant of pi by 6? Cosecant is 1 over sine, okay? It's going to be 1 over sine of pi by 6. And we know sine of pi by 6 is 1/2. So that's going to be 1 over 1/2. Okay, and that has to be squared. So let's go back and let's square that. And if you take 1 divided by 1/2, that's going to give us 2. And 2 squared is equals to 4. Okay, so we verified that this this is an identity. This is true for pi by 6. Okay, so therefore, okay, cotangent square theta plus 1 is equals to cosecant square of theta for pi by 6. Okay, good. Now let's take a look at example number 2. Any questions there? You okay? Let's take a look at example 2. Okay, what are we trying to verify? We're going to try to verify if this is true for this particular value. Is it true for that value? Let's see. First, tan squared theta plus 1. Okay. So we're going to put, oh, this is kind of weird. We're going to put theta in here, okay? We're going to replace x with theta. Right there. So we're going to put 3 pi by 4 where there's theta. So tan squared of 3 pi by 4 plus 1. Now we look at 3 pi by 4. Again, that one is a special angle. Let's see if we can visualize where that is. So 1/4, 2/4, 3 pi by 4 is over here. Right? So 3 pi by 4 is over there. And what's the coordinate here? Negative root 2 over 2, comma, root 2 over 2. Yeah, it's good. Negative and then positive. Now, this is the cos of 3 pi by 4, and then the second part of this coordinate is the sine of 3 pi by 4. But we want tangent of 3 pi by 4. So how can we figure out the tangent? The sine over cos. And sine over cos is just negative 1. So this is going to be really negative 1 squared plus 1. And that's going to give us 1 squared is 1 plus 1 is 2. So that value, it boils down to 2. Now what about secant square theta? Secant square theta, we're going to replace theta with 3 pi by 4. Now what's secant? It's the reciprocal of the cos. So this is going to be 1 over cos cos squared theta. Yeah, we can have the square on the outside or on in the inside. I'll try to be consistent. Okay, so 1 divided by that's going to give us negative 1 over negative root 2 over 2, which is it's a square. This is going to be reciprocal. It's going to be negative 2 over root of 2 square. So when we square that, that's going to give us 4. And when we square the 2, it's going to be 2. So it's still going to be equal to 2. So that shows that, therefore, tan squared theta plus 1 equals secant squared theta for theta being 3 pi over 4. Now, we already know this piece, right? That tan squared theta plus 1 is secant squared theta. So if we look at our identity sheet, this is true for all values of permissible values for theta. So it works for 3 pi by 4, but there's other solutions that where both of them are going to be equal to each other. You okay so far? Yeah. Last but not the least is example number 3. Secant x is more complicated on one side, but then the other side is the other side is not bad, sine theta. Okay, so verify the equation for secant x over tan of x plus cotangent of x is equals to sine of x. We're going to verify if it's true for 30 degrees, and we're also going to verify for pi by 4. Okay, so we're going to take a look. We're going to do 2 of them. Okay, so let's start with the 30 degrees. Where's 30 degrees here? Let me just see the visual. So, okay, 30 degrees is right there. Okay, now I know what 30 degrees is, even though I don't know what secant is yet, tan and cotangent, but I know that this coordinate for that particular terminal angle is going to be root 3 over 2 comma 1 half. And then this is the cos, and then theta, sine theta. Okay, so we're just going to straight plug in the numbers in here so you can go ahead. So secant x, secant 30 over tan 30 plus cotangent 30. You're going to see what that is. Secant 30 divided by tan 30 plus cotangent 30. Okay, what's a secant 30? It's going to be the reciprocal of the cos. So it's going to be 2 over root of 3. All of that is divided by tan of 30. Well, what's tan of 30? It's going to be sine 30 divided by cos 30. So if you take sine 30 divided by cos 30, it's going to be 1 half over root 3 over 2. Is that okay? We're going to have like a little bit of a complex fraction, and that's okay. Plus cotangent 30. Well, what's a cotangent of 30? It's going to be cos over sine. Right. So cos is going to be root 3 over 2 over 1 half. Okay. So let's see. This one, leave it alone for now. 1 half divided by root 3 over 2. The 2 would cancel. And then the 2 would cancel here. We're going to be left with 2 over root of 3 over 1 root of 3 plus root of 3. Okay. So how can we do this piece? Find a common denominator, right? So what's a common denominator? Root of 3. What was that? Root of 3? Is everybody okay? Yeah, because this is the denominator 1. We're going to make root of 3, root 3. That's the lowest common denominator of this denominator. So what does it boil down to? 2 root 3 over 1 root 3 plus root of 3 times root of 3 is 3 root 3. Okay, what's next? That's going to be 2 root 3 over 4 root of 3. And then the root of 3's cancel. You're left with 2/4, which is a half. So all of these, secant 30 divided by tan 30 plus cotangent of 30 degrees has a value of 1/2. Now what about sine of 30? It's 1/2, right? So that one is true. Now what about pi by 4? Pi by 4, where's pi by 4? Right there. It's going to be root 2 over 2. Root 2 over 2 is the coordinate on a unit circle. Right? So for this one here, it's going to be root 2 over 2, comma root 2 over 2. I'll just write it on this side. That's a cos of pi by 4 and sine of pi by 4. So if we evaluate this using pi by 4, what would it be? Okay, secant of pi by 4 over tan of pi by 4 plus cotangent of pi by 4. Okay. Let's see, what's a secant of pi by 4? It's a reciprocal of cosine. So if it's the cosine, we're going to take the reciprocal of that, which is 2 root of 2 divided by tan of pi over 4. It's 1, right? Tan is sine divided by cos. That's plus, what's cotangent of pi by 4? The reciprocal of this, okay? This is going to be 1 as well. Okay, now what happens? This is going to be 2 root 2 over 2. Okay, what would that be? Nothing cancels. So it's going to be 2 root 2 times, 1/2. 1/2 would, it's going to be 1 root of 2. So when we substituted pi by 4 into this expression, it comes up to 1 over root of 2. Now I'm going to ask you this. Well, what's sine of pi by 4? Root 2 over 2. Okay, now you're probably thinking, oh, they're not the same. Yeah, yeah. So when we look at this, this doesn't look like they're equal to each other, right? But here's what we could do. The denominator of this is an irrational number, and the denominator of this one is a rational number. So how can we take the root of 2 in the denominator? So we can say, oh, okay, I can go rationalize the denominator. I'll write that down. Rationalize denominator. Okay, so we're going to multiply by 1 in the form of root 2 over 2. And what happens here is that you have 1 times root of 2, which is root of 2. And then root of 2 times root of 2 is 2. So now they're the same. So might not be exactly the same to begin with, but then if we had to rationalize the denominator, it will be exactly the same. Yeah. So in terms of verifying, this is what it means. You substitute. It's like checking your answer to see if they are correct. Oh, hi. So far so good? Yeah? Okay. So that concludes that lesson. We went back to lesson 3, which we've seen that already before, right? It's nothing brand new.